Let's start with a basic setup. Our AKS cluster connecting to Azure PostgreSQL over its public endpoint. Traffic flows through the internet to reach the database on port 5432. And here's the first problem. That public IP is reachable by anyone. An attacker can send brute force attempts, SQL injection, credential stuffing. All of it reaches the database. The auth holds, but every attempt still hits the server over the public internet. A zero-day attack could take us down. Legitimate traffic and attack traffic use the same endpoint. The database is protected by authentication alone. One layer. Let's fix that. Step 1. A PostgreSQL firewall rule. We allow only our AKS cluster's egress IP. Now the attacker's connection is refused at the network level. The firewall drops it before it even reaches authentication. But then we add some cloud-native Azure functions. They're serverless. Every time they scale, they might get a different outbound IP. We can't add them to the allow list because we don't know what their IP will be. So we check this box. Allow public access from any Azure service. The functions connect. Problem solved, right? Allow Azure services means any Azure service, including an attacker's VM on their own Azure subscription. That checkbox doesn't distinguish your services from anyone else's. It's not a security boundary. IP-based security doesn't scale in the cloud. Services move, IPs change, and the allow-all escape hatch defeats the purpose. We need a model based on network identity, not addresses. Azure Private Link. We create a private endpoint, a network interface inside our VNet with a private IP, 10.0.2.10. This connects to PostgreSQL through Microsoft's backbone network. Traffic never touches the public internet. The only magic here is the magic of DNS. The pod connects to mydb.postgres.database.azure.com. Same connection string, no code changes. But DNS now redirects through a private DNS zone linked to our VNet. The hostname resolves to our private IP, 10.0.2.10. Note the CNAME with private link in it. But what about clients that aren't on our VNet? Here's the key. They query the same hostname, and public DNS returns the same CNAME. mydb.privatelink.postgres.database.azure.com. The CNAME is always there, but without a private DNS zone linked, that private link name falls through to public DNS, which resolves it to the original public IP, 40.78.x.x. Same connection string, same CNAME, but a different final answer. The private DNS zone is the fork in the road. Until we explicitly disable public access, both paths work side by side. AKS connects. VNet integrated functions connect through the same DNS zone. No firewall allow lists, no checkboxes, no static IPs to track. Same connection string. Zero code changes. Now we disable public access. The public IP is gone. Allow Azure services means any Azure service, including an attacker's VM on their own Azure subscription. That checkbox doesn't distinguish your services from anyone else's. It's not a security boundary. And inside the VNet, network security groups restrict which subnets can even reach the private endpoint. Defense in depth, but now every layer is meaningful. We went from a public endpoint anyone could reach, to IP rules that broke when services scaled, to a checkbox that let everyone in, to private link, where the database lives on your network and DNS handles routing. No static IPs, no checkboxes, no public surface. Azure Private Link. The best firewall rule is no firewall rule, because there is no public endpoint at all.